Hey folks, welcome to the new video. So as discussed in this video, we'll be going through some basic statistical metrics that we use to make sense out of data and like take decisions as such, like informed decision as such, so that we can make better decisions and we make them being aware of what problems it might cause or what are the trade-offs that you're making, right? So let's dive into it. So if you like, this is probably something that you have already done in school or college or whatever, right? But here we'll basically go through it so that we can implement it in the future videos, and we'll see how it can help us benchmark things or how it can help us decide things on our day-to-day basis, right? So yeah, let's get started. So we have statistical metrics. The first one, it's sorry about that. First one is mean. Okay, cool. So what is mean? So mean is basically the average of whatever data set you have. Let's say whatever data you have collected for whatever metric you are trying to optimize for, you average them out and you get the mean. Let's say you have calculated some memory versus time graph, right? So time is on the x-axis, memory is on the y-axis, and you are running some calculations on a code that you have written. Then the mean would be, let's say, sum of all whatever memory values that you have and average out by the total number of values. That's mean, average. Then we have median. Median is the value in the middle. Let's say you have 1,000 data points. The value at the midpoint of the data set would be the median, and intuitively it might seem like it would be the same as mean, right? But that will not be the case for some use cases. That will be the case for many, but for many that won't be the case as well, because if you assume a very non-uniform distribution where you have no specific way to track it, or let's say a very disproportionate sort of a distribution, right? Or a very weird curve that you cannot predict what will the value be, like if you extend the curve till some X amount of value or something, right? So in those cases, median and mean won't be the same, and it's mostly because of something called outliers. So those are the things, outliers as in, let's say if you assume a normal distribution like this, right? So it's like this, and towards the end it goes for a very long length, and towards the start it's like this. Okay, so in that case, let's say the values at the end are causing the mean to change, and it's not the same as median. So those are sort of the outliers, and median somewhat signifies, if we compare these two values, we get an idea about what the outliers might be and where those might lie, right? So that's the median. Then there's standard deviation. Standard deviation, there is a formula for calculation. You can go through it. I won't explain it here. Like, it's very straightforward. You just mug it up and you can calculate whatever you want. You can write the code for it. But the thing that standard deviation signifies is how significantly will the input affect the output, right? So if you calculate something, you would want to know how predictable would the output be, or what's the worst case possible if you tweak the input based on whatever input you are predicting to have, right? So let's say you are expecting these many requests per second or something, right? So how will that affect the performance of a system, right? So higher standard deviation means for a small change in input, there will be a huge change in output. So those are not very good for, let's say, efficient like performance system if you want to build, and if you cannot predict the input, maybe it's good to have a smaller standard deviation, like if you don't have the number of input. But again, those are complex systems to build. If you want to keep it simple, sometimes you have to do a trade-off here. If you have certainty on how much the input could be based on that, right? So everything is trade-off, like I said. And then we have variance. Variance is sort of similar to standard deviation. We just like add a square, and that's variance. It also sort of helps us measure how dispersed the data is, and how the input can change the output as such. So yeah, these two sort of are similar, and we'll like see those in application, and will be better to understand there. So yeah, this should be it for this video. I think it's already 5 minutes, but yeah, I think we covered it well. And if you have any doubts, you can ask. If you are facing some issues in understanding it. I wanted to discuss something else as well, but I think I'll make a separate video out of it. So I wanted to go through these distributions and how can we make sense out of it, right? So we have this standard deviation, mean, median calculated for this skewed distributions and stuff. I think I'll do it in the next video, but just try to wrap your head around this, right? So these are sort of very similar things, but very easy to get confused also. So let's go through them once again. Mean is the average of whatever you calculate. Median is the value that lies in the middle of whatever data you have collected. Standard deviation has a formula, you can check it up and calculate it, but what it signifies is how drastically will the output change if you make a change in the input. So our goal, if we want to make a performance system where we cannot predict the input, would be to keep it less, right? So, and variance is sort of a similar function as standard deviation. We square it up, and it's also tells us that, like, gives us an idea about how the output might change depending on the input. So yeah, that should be it for this video. If you like the video, just leave a comment. If you have any suggestions, you can drop a comment. If you want me to make or cover some other topic, that also, of course. And if you find it helpful, maybe share it with your friends. And yeah, see you folks. Bye.